find the mean and standard deviation of first in natural numbers. Let the first in observations be 1, 2, 3, 4, n. We know that sum of first all observations, first all in observations is 1 plus 2 plus 3 plus n is equals to n plus 1 by 2, and sum of square of first all n observations is 1 square plus 2 square plus 3 square n square, which is n plus 1 2n plus 1 whole divided by 6, right? Now, mean is basically equals to sum of all observation by n. So, our mean will be 1 by n times 1 plus 2 plus 3 plus n, sum of first n observations. So 1 by n times n plus 1 by 2, which gives us n plus 1 by 2. And we know that variance is basically 1 by n summation xi minus x bar whole square, which can also be written as summation of xi square by n minus summation xi by n whole square, which can also be interpreted as mean of squares minus square of the mean. Now, we know that to calculate sigma square x, we first have to calculate summation xi square. So 1 by n times 1 square plus 2 square n square minus, we recently got the summation of xi by n, which is mean. That's why we can easily write this as n plus 1 by 2 whole square, as x bar is basically n plus 1 by 2, which is basically summation xi by n, right? So this is basically, we can write 1 by n times n plus 1 2n plus 1 whole divided by 6 minus n plus 1 by 2 into n plus 1 by 2. So this can also be written as n plus 1 times 2n plus 1 by 2 into 3 minus n plus 1 by 2 into n plus 1 by 2. So if we take n plus 1 by 2 common, we will get 2n plus 1 by 3 minus n plus 1 by 2, right? So n plus 1 by 2 times the LCM of 3 and 2 is 6 times 4n plus 2 minus 3n minus 3. So n plus 1 by 2 into n minus 1 by 2. So we are getting n square minus 1, sorry, this is 6, n square minus 1 by 12. So if this is the variance, Therefore, we can write the standard deviation as root over of n square minus 1 by 6 into 2, which is 12. Similarly, we can calculate the sum of first n even observations. So if we write the first n even observations as 2, 4, 6, 8, the last term would be 2 times n, then uh, mean we know that we need to calculate summation xi by n. So basically if I take 1 by n common, we will get 2 plus 4 plus 6 plus 8 plus dot 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 2n. Now if I take 2 common, I will get again the sum of first n observations, 1 plus 2 plus 3 plus dot 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 n, right? So basically 1 by n into 2, again we will use that formula, which is n plus 1 by 2. So we are getting the mean as n plus 1. And again to calculate sigma square x, that is variance, we need to calculate summation xi square by n minus summation x by n whole square. So here summation, now first we need to calculate the summation xi square, right? So summation xi square is 2 square plus 4 square plus 6 square dot 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 2n whole square. Now 2 square is 4, 4 square is 16, 6 square is 36, then again 8 square is 64, and similarly the last term will be 4n square. Now, if I take 4 common, I will get 1 plus 4 plus 9 plus 64 divided by 4 is 16, 9 plus 16, and the last term would be n square. So basically, this is the sum of first n square terms. That means 1 square plus 2 square plus 3 square plus 4 square, and the last term would be n square. So we can write this as 4 times n plus 1, 2n plus 1 times 6. This is my summation xi square. Therefore, summation xi square by n will be 1 by n into 4 n plus 1, 2n plus 1 whole divided by 6, and we have one n over here, which again will get cancelled out. So we will get 4 times n plus 1, 2n plus 1 times 2 into 3. So basically this is n plus 1, 2n plus 1, 2n plus 1 divided by 3. This is my summation xi square by n. Now, we know sigma square x as summation xi square by n minus summation xi by n whole square. We now will use the result that we got. So basically summation xi square by n is 2 times n plus 1, 2n plus 1 times 3 over 3, and summation xi by n is basically n plus 1, right? Because this is our mean for even numbers, summation xi by n. So basically we need to square it, n plus 1 whole square. Now if I take n plus 1 common, I will get 4n plus 2 by 3 minus n plus 1. That means n plus 1 times 4n plus 2 minus 3n minus 3 whole divided by 3, right? So basically this is n plus 1 times n minus 1 by 3. So this is n square minus 1 by 3. Therefore, if variance is this, then standard deviation will be square root of n square minus 1 by 3. Now, we need to calculate the sum of first odd numbers as well. So we can write the odd numbers as 1, 3, 5, 7, 9, dot, 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 2n minus 1, right? Because if we take any number like 10, so 2 into 10, 20 minus 1 is 19. So always 2n minus 1 or 2n plus 1 is a odd number. Now, again to calculate mean, we need to calculate the sum of first now odd terms. So 1 plus 3 plus 5 plus 7 plus 9 plus dot 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 dot. The last term would be 2n minus 1. Now I can write 1 in terms of 2 into 1 minus 1, 3 in terms of 2 into 2 minus 1, 5 in terms of 2 into 3 minus 1. Similarly, 7 in terms of 2 into 4 minus 1, and on and on and on. And the last term would be 2 into n minus 1. Now, if we see that in each bracket, the first term is multiples of 2. So if we take 2 common from first terms of each bracket, I will get 2 times 1 plus 2 plus 3 plus dot 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 n. Again, the sum of n terms. And the second term in each bracket is basically minus 1. So if I take minus common, I will get 1 plus 1 plus dot 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 dot, dot 1. So here there are n ones. That means we can write 1 into n, which is n, right? So we can write this as 2 into, sorry, we can write this as 2 into n, n plus 1 by 2 minus 1 into n, which is n. So if I cancel out 2's, then I will get n square plus n minus n. So that is basically n square. Therefore, if summation xi is n square, then summation xi by n will be n square by n, which is n. Therefore, this is basically our mean. Mean is basically x bar is basically n, right? Similarly, to calculate the variance, first of all, we need to calculate summation xi square, right? So in this case, this would be 1 square plus 3 square plus 5 square, dot, 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 dot. The last term will be 2n minus 1 whole square. So again, we can write 1 square in terms of 2 into 1 minus 1 whole square plus 2 into 2 minus 1 whole square plus 2 into 3 minus 1 whole square dot 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 dot. The last term would be 2 into n minus 1 whole square, right? So now basically this is the formula of a minus b whole square, where the first terms can be collectively write we can collectively write this as 2 square into 1 square plus 2 square into 2 square plus 2 square into 3 square dot 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 dot. The last term would be 2 square into n square. Now the second term in each bracket will be a minus term, right? So if I take minus common, the first term from the first bracket will be 2 into a. A is 2.2 into 1 into 1. Similarly, the second term in the second bracket would be 2 into 2 into 2 into 1. Then the third term would be 2 into 2 into 3 into 1. plus dot 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 dot. The last term would be 2 into n into 1. This is basically the two AB terms. Now the last term would be 1 square plus 1 square plus 1 square. So we can write this as plus 1 square plus 1 square dot 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 dot. The last term would be 1 square, right? So we can see that from each term in the first bracket here, the two squares are common. So if I take 2 square common, we will get again the sum of first square of first n terms, 1 square plus 2 square plus 3 square dot 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 n square minus, here we can take, see, we can take 4 common. So if we take 4 common, then in the first term would be 1, the second term would be 2, then 3, then 4, and the last term would be n. And again, similarly, by the same reasoning, we can write the sum of 1 square is basically n. So here the 2 square is 4, and we can use the formula n plus 1 to n plus 1 whole divided by 6 minus 4 into n plus 1 by 2 plus n, right? This is our summation xi square. Now if I divide this summation xi square by n, I will get 4 n plus 1 to n plus 1 by 6 minus 4 times n plus 1 by 2 plus 1. Now to calculate the sum sigma square x, that is variance, we can use the formula summation xi square by n minus summation xi by n whole square, right? So our summation xi square by n, summation xi square by n is basically 4 n plus 1 to n plus 1 times 6 minus 4 n plus 1 by 2 plus 1 minus, we are getting summation xi by n as n. So summation xi by n whole square is n square, right? Okay. Now we can write this as 2 times n plus 1 to n plus 1 by 3 minus 2 times n plus 1 plus 1 minus n 1 plus n. Now if I take n plus 1 common, n plus 1 common, I will get 4n plus 2 by 3 minus 2 plus 1 minus n, right? 1 minus n. Now, if I take LCM, then we will get 3, 4n plus 2 minus 6 plus 3 minus 3n. So this is basically n plus 1. 4n minus 3n is n. 2 plus 3, 5 minus 6 is minus 1 by 3. So basically we are getting n square minus 1 by 3. So the standard deviation sigma s will be lower of n square minus 1 by 3. Now the summary that we are getting is that in case of mean, for all n natural numbers, we are getting this as n plus 1 by 2. And for even terms, we are getting n plus 1, and for odd terms, we are getting this as n, which is very obvious because for even terms, the mean will be n plus 1, and for odd terms, it will be n just exceeding one more term. And now is the important thing is if we see the sigma square x, or if we see the standard deviation. If we see the standard deviation for all natural numbers, we are getting as n square minus 1 by 12. And for even terms, we are getting n square minus 1 by 3. And for odd terms, we are getting n square minus 1 by 3. These two are similar because even and odd terms, they are consistent. 1, 2, 3, 4, dot, 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 dot. So the even terms and the odd terms are just have a similar differences. And n square minus 1 by 12 can also be written as 1 by 2 root over n square minus 1 by 3, right? So basically, which means that our calculation is correct. And for first n natural numbers for me to calculate me, we are using these formulas and getting the results. Thank you for watching.